Now on to example 5. This is going to use the exact same tactic that we did in the previous example to simplify and to rationalize the denominator. So here we're looking at minus 2 over square root of 27. So odds are we're going to have to break up this 27 into powers of 2. Okay, so how does this work out? We have minus 2 over root 27. First thing we're going to do is rationalize that denominator. We don't want a radical in the denominator, so what we're going to do is multiply cleverly by 1 by multiplying by the denominator, top and bottom. So what this gives us is minus 2 times root 27 over root 27 squared. Okay? So since we have a number on the inside that's positive, and we have a square root and a square, the square root and the square cancel off. So this gives us minus 2 times root 27 over just 27. So now 2 does not go into 27 at all. So we can't really do any cancellation this way like we were able to in the previous example. But we probably can simplify this radical a little bit. So anytime we have a radical of a big number, odds are we can factor the big number on the inside using a factor tree so we can simplify the radical. So we have 27 is 3 times 9, and 9 is 3 times 3. So this is helpful because we're looking at a square root, and we have a cluster of 2 3's here and a spare 3. So I can rewrite this as minus 2 times radical 3, my spare 3, times 3 squared. And this is all over 27. So far, so good. And now I can use the product rule for radicals. So I can break this up into 2 separate radicals and cancel off this 3 squared. So I have minus 2 times square root of 3 times square root of 3 squared, all over 27. Okay? So, as I mentioned before, the 3 squared and the square root cancel off, and that leaves us with minus 2 times square root of 3 times just 3. 3 is not inside a radical anymore. And now this is all over 27. Notice, though, I have a 3 over 27 here. Yes, I could combine the minus 2 and the minus in the 3, so I get minus 6. But I notice that 27 is divisible by 3. So I can cancel off one of the 3's inside 27 with this 3. So I have 3 over 27. Well, that's just 1 over 9. So writing that out, I have minus 2. I did nothing with that guy. So I have root 3, but I canceled off one of the 3's in the 27 to get rid of this 3. So this gives us 9 in the denominator here. This does not get any simpler than what you see here in my last step. I have a minus 2 times root 3 all over 9. Can't be any simpler. So with that, we are done with this example, and we're going to start moving on to harder ones in difficulty 2.